Okay, so we talked about this in class, but I'm going to just briefly run down the different ways we talk about solutions to inequalities. So generally, when we finish solving an inequality, we end up with a variable, and then we have some inequality symbol and our constant or our number. So this, in words, we say x is less than 3. Now, as we said in class, this is strictly just a rule. It is not technically a solution set, though most of us sort of consider that we're done when we get here. So we had some other solution options. One was to use what math people use, and that's use set builder notation. In order to do set builder notation, we just took and threw this little x with a bar in front of our rule and threw some curly Q brackets on it. This is because, as we said in class, the squiggly brackets, these tell us this is a solution, heads up. That's what these things tell us. As soon as you put something inside of them, it's now a solution instead of just a rule. And then the bar here tells us as long as what's behind here is true. And we use this notation with that bar actually a lot when we get into statistics and we start talking about probabilities. So this in words would say, hey, look, there's a solution. It's any x as long as this is true, that x is less than 3. Like I said, I'm going over this because other instructors may expect you to know it, but it's a very mathy notation. It's not something I will test you on. So the next way we can talk about our solutions is in a graph. The nice thing about a graph is that it lets us visualize what the heck is happening. So our graph, we usually have a number line because we're only dealing with one variable, which is our x. We go up to whatever our number is, 3. And here's where we have a number of options in terms of this graph. First off, the way I was told, I'm going to go ahead and give myself 2 number lines so I can do the way I learned and then the way books currently do. So the way I learned this was that you just put an open circle at 3, right, at that number. And then you decided, do I need to fill in the circle or not filled? So this would be an open, if we had a greater than or strictly less than with no equal to sign, and it would be a filled circle if we had the equal to sign to say that it can reach that number. And then since it's a less than, or since our arrow goes in this direction, our inequality, we're going to shade everything that is less than 3. Now, the newfangled way of doing this is to jump ahead to kind of what we're going to need when we talk about the interval notation, and that is, instead of putting an open circle or a closed circle, we're going to use a parentheses if it doesn't actually get to that number, if we don't have the equal sign, and we'll use a bracket if we can actually reach that value, if it's in the data set. Now, the reason why I don't like this as much personally is that you have to think about which way you're going to have to shade because you want your parenthesis to catch it. You wouldn't want to draw a parenthesis that went this way and then shade that. You actually want to have your parenthesis come this way because we don't have an equal sign in ours, and then catches all of that shading that goes off to the left. So either of these is acceptable, and this is something I would have you do on the test, totally. Now the last is the thing that you're going to see the most often in statistics and in sciences, and that's interval notation. So I will make you write your answers this way on a test. We saw this in class. Interval notation, the easiest way in my mind to go from there is to look at your graph, because if you can do the graph, you can do interval notation. So I'm just going to rewrite my little graph here. So we're still looking at x is less than 3 as our rule, trying to figure out a way to talk about that. We have, whichever we want to do, I'll do the parenthesis one. So there's our number line. So with interval notation, like I said in class, you always want to write your interval notation smallest to largest. It always has to be the smaller one on the left. And that's why the graph is very convenient, because you can actually see your smallest and your largest possible value. Now, in this case, there is no smallest value. We are going off forever and ever and ever towards negative infinity. But you can just remember this is always negative infinity. The right arrow is always positive infinity. So we bring down to negative infinity. We bring down the 3. And then 3 already has a parenthesis here if you use that notation. So you just bring down the parenthesis with it. Infinity always gets a parenthesis as well. So our true interval notation for this is negative infinity to 3. So somebody can look at this and they know, okay, any number will work as long as it is something between negative infinity and 3, and we're not including 3 in the solution because we're using that parenthesis. So there are a ton of different ways that this inequality notation can go, and I have a lot of them in the JITT, which is why I'm giving you guys this quick video. So let's do a rundown of those interval notations and what could happen. So interval notation continues. Okay, so we have done the example in class and the last one both had a less than, right? So there's a bunch of different options. We did this in class, less than or equal to 2. I don't remember what my JITT is. I don't want to use the same number because at least then I can make it slightly more exciting, right? I used 2 in the JITT. I'm changing it. So let's do less than or equal to 3. X is less than 3. X is greater than or equal to 3. And X is greater than 3. This is basically the 4 different ways this can go. We've already seen the first 2. The second one was one we did today, right? So we started at 3 and then we went over. In class, we did the less than or equal to. Only difference is instead of using an open circle or a parenthesis, you're going to be using a closed circle or a bracket. So when you actually think about your interval notation for these two, only difference, still going to be negative infinity to 3 for both of these, right? Infinity always gets a parenthesis because we cannot truly reach infinity. And then the only difference is this one has an equal to, so it will get the hard bracket, as I said in class. Kind of see the equal to part on that bracket. And this one does not, so it'll get the parenthesis. The greater thans, very similar. Only difference is that when we come to 3, for the greater than, we're going to shade above 3, right? And above 3. So we will include 3 with the equals to it. We'll use the hard bracket, and we'll have a parenthesis on the bottom one. So this changes up our interval notation, because now look at the area we shaded. The smallest thing is the 3, and the largest thing is the right-hand arrow, which, as I said, is infinity. So same thing for both of these. They're both a 3 to an infinity. The infinity side is always going to get a parenthesis because we can't truly reach it. And then it's all about whether or not we have an equal to. So there we have an equal to, and there we don't. There is one more thing that can happen with this interval notation, and that is what we call a compound inequality. So that would look something like this. So one way to think about this in terms of what this means is x is, and now you see the x, this has a little alligator eating the x, so x is actually greater than 1, because the 1 has got the smaller sign, right? And it is also, 3 is being the one eaten, so x is less than 3. So that's one way to think of this. X is greater than 1 and x is less than 3. To me, this is more mathematical. It doesn't actually help me at all with understanding it, so I don't love that definition. The definition I think makes a lot more sense is just thinking this is x is between 1 and 3. One thing you do want to make sure, because if you did solve an equation, it's possible that something funky can happen here, and I'll show you what an example of that is. But you do want to make sure that if you were to ignore the x, like if you could just take the x out of here, does this make sense? 1 is less than 3. Yep, it makes sense. So since that's true, we can read this as x is between 1 and 3. So what does that look like in terms of our graph? We have 1, got 3. X has to be between those, right? So if we were going to shade where this is, x is somewhere between 1 and 3. Can it equal 1? No, because we don't have an equal sign. So we're going to put a parenthesis there. Can it equal 3? No, because we don't have a parenthesis. So it's got we don't have an equal sign, so it's a parenthesis as well. So what does this look like in terms of our interval notation? Well, the smallest thing that's on our number line is the 1 up to a 3, and they both have parentheses. So this is shorthand for that, saying that any value between 1 and 3, not including 1 and 3, will work. Now, if this changes, and we have, say, like something like this equal to only applies to the 3. It doesn't apply to the 1. So if we wanted to draw this one out, 1 does not have an equal to, so it will have a parenthesis, where 3 does. So 3 will have our bracket. So we have a parenthesis and a bracket, and then we're shading anything between that. So same thing is going to translate to our interval notation, 1, 3. The 1 has a parenthesis and the 3 has a bracket. So we could do this all day long. The only other combinations of this, which I'll let you guys finish if you want, but I'm not going to do, we could have the equal to on the 1 instead of on the 3, or they could both have equal tos. If you really want to try those out, pause. I'll go ahead and just skip right to the answers here for you. This one would be 1 to 3, and this one would be 1 to 3. One thing that does confuse students a lot is that us math people annoyingly use the same notation. This 1 to 3, the way you see this here, looks like an ordered pair, right? There's no difference between this point and this interval in terms of the notation of it. So the question is, are we talking about this point, or are we talking about this here, the range of values? And that's all just about context. So I just want you to realize, yes, this looks like an ordered pair. It is not. These are two separate things. We just happen to use the same notation for both. And I apologize that it's confusing, but that's just the way it is. So this is a solution set. This is a point on a graph. Oh, and the last thing I was going to show you is how this could get screwed up potentially. When I was saying make sure that the 1 is less than the 3. This probably would never happen, but it could, so I have to mention it. The only time I've ever had it happen is like when I make a mistake in a class of my own. You could have a question that's this compound inequality, this 3-part inequality piece, where say we're looking at, my brain is failing me at the moment. Say 2 is less than x. Oops, no, I want an x. Let's make this 3x is less than 6. No, I need to make it not work. Sorry, my brain is not good at this. -6. So if you want to solve a 3-part inequality, it's just like solving a 2-part inequality, but instead of having the 2 sides do the same thing to, you just do the same thing to all 3 pieces. So this is completely allowed, to divide every piece through by 3, so that we can get it to look like we saw in the other thing. So 2/3 is less than x is less than -2. Now, this is the issue. Obviously, it was a little silly in this question, but it could be less obvious. If I erase this x here just to look, is 2/3 less than -2? No, I would rather have 2/3 of a dollar than owe someone $2. So there is no such thing as a number that is both bigger than 2/3 and less than -2. So this is actually, since this original 2/3 does not less than -2, right? That's not true. This would be a no solution. Again, I don't think this would happen. I just don't want to lie to you guys and say it always works. Just imagine it's between, because that's why as math people think of it as this piece and this piece, because then we can see, oh, there's nothing that fits both those rules. So anyways, that's your introduction to our solution sets. Again, I'm going to focus on the graphs, right? So our little number line graphs and our interval notation. So what's important is that you're able to do both of those pieces.